And hello everyone, welcome back to another C++ tutorial. Today we'll be talking about pointers. This is usually where a lot of people start struggling with C++, because pointers is basically memory management. It's more of a large part in C, but it's also used a lot in C++. So let's get started with what exactly is a pointer. Well, a pointer is something that points, so imagine like someone pointing to an address in the memory. So here we have our RAM. So imagine this is literally our RAM stick that we put inside of our PC. And it has all of these little things here. Okay. Now, when you put something in the RAM, let's say the variable x. So you have the variable x which is equal to 10. The variable x then has a special address, something similar to the lines of, I don't know, let's say 3, 4, A, X, Z, P, I don't know. It is a similar address to this. This address is where x can be found inside of the memory. So let's say this address corresponds to right here in the RAM. It's the address. Now, when we want to get x, what it usually does is it goes to this address and it says, hey, address, what do you store? And this address says, hey, I store 10. And it comes all the way back and it's like, hey, this address stores in x the value 10. That's usually what happens when we try and set a variable. So if we were to go here to our code and we were to say int x is equal to 10, and then we were to say cout x. That's basically what's happening here. We're saying, hey, this x variable should have this address and it should contain this value. Then we store it in here. Then we try and get it. It's like, hey, this x variable here, what does it store? So it goes to this address, it checks, and it brings back and it gives us that. Another way that people also like to do it, then we can actually discard this, to explain it, is to use houses, because houses has addresses. Just excuse my terrible drawing. Because every variable is housed in its own house. This is a variable. This could be variable x. This could be variable y. It has an address. So this could be 44AXF, I guess. And this could be 92AXF. Or E, whatever that is. And this is an address. When you think of a memory address, you should think of a house. It's an address. If someone asks you, hey, what's your address? That means, hey, where do you belong? It makes sense, right? So if I ask X, hey, X, what is your address? They return me this, and then I can go to the memory, and I could search for this address to find where X lives. So I can go to X's house and get the values that are inside of this house. Now that's the basic concept. A lot of people overcomplicate this. They think that a pointer is much more than this, but it's really that simple. That's something you have to kind of wrap your head around, because a lot of people struggle here because they don't really realize how simple the logic behind a pointer is. A pointer is just an address in memory. That's all a pointer is. With that knowledge, let's go here. So we have x here. If we print x by saying cpile, we get 10. If we print %x and we compile and run that, we get its memory address, what we just talked about. So this is where x is in your RAM. This right here, that is where x is in your RAM. Every time you run this program, there's a chance that this will be different, because x is, every time you run the program, x is stored in a new location. It's being redeclared, so it's given a new address in memory. So doing this, we can get the address in which x resides. You could also declare pointers. For example, let's go here and say int p1 for pointer 1. And if we add an asterisk here, it means that this here is a pointer. Now some people like to have the asterisk here, some like to have it here, and some like to have it here. Where you have the asterisk doesn't really matter as long as it's after the type and before the variable name. But now we are declaring a pointer. This pointer doesn't have a value. However, we could give it a value by saying this pointer contains the value or is pointing to X's address. This might seem a bit confusing, but if we go here to cout and we cout P1, so we cout this pointer 1, we get this. This is strangely enough the same that you'll get if you print out this. That is because this just stores this address now. This address here, that's all it does, it just stores it. So when we print it out, we get this address. We don't have to use an ampersand here to get the address because it is already an address. We're saying here it's an address, it's pointing. So here it displays the address. To dereference a pointer, this means to get the value inside of a pointer. You could use your asterisk here. Now if we were to run it, we'll get the value that is stored inside of this pointer. So by using an asterisk, you can get past the location and just get what you want. Of course, this means if you were to do this, this is perfectly valid code, where we get the value inside of this reference, inside of this address. So X address, and then get the value inside of it. So this will give us 1010. So let's say you have a pointer and you want to store the value inside of that pointer inside of another variable. That means you can go int val, that will be equal to asterisk P1. And this will store the value inside of P1 like that. And just like that, we have worked with a lot of spaces inside of memory. I'm not going to go too deep into pointers just yet. I think we should take it step by step because I think that would probably be the easiest way to understand what a pointer really is and how it works. So to get back from the start, let's just go through it one more time. A pointer points to the location of a variable in the memory, in the RAM. It gives you the address of a variable. And whatever is at that address is whatever is inside of the variable. Using an ampersand means point. So point to this variable address. So this ampersand here, this means give us the address of this variable. By using an asterisk when declaring a variable means that you want to store a pointer. You want to store the address. You don't necessarily want to store the value. And then also using an asterisk, you can dereference a pointer and get the original value inside of it. And you might not see the use for it yet, but sometimes you need to edit a variable specifically. You don't want to edit a new variable, like when you pass it into a function. You don't necessarily want to get a new reference of that variable, like a new version of it. You want to get that specific variable. Then at that point, using a pointer is a good idea. But yeah, that is for a future tutorial. Thank you for watching. I hope you all enjoyed, and I'll see you all again in the next C++ tutorial.